everybody. Welcome back to Shannon's Lumber Industry Update. This is episode 38, and today we're continuing our series on plywood. Today we're going to focus entirely on the face veneers, and this is kind of important, right? Because it's what we see. And in fact, the grade, when you buy a sheet of plywood, the grade that you buy, A1, B4, D3, etc., those letters and numbers refer specifically to the grade of the face veneer. It has nothing to do with the core. So let's get that out of the way right now. Unlike lumber, where you can buy FAS or Select or Common and you can expect a certain number of defects, this is the same idea with plywood, where by choosing that grade, that B or A or C, first of all, the front face will always be a letter, A, B, C, D, all the way through E, if I remember correctly. The back face is numbers, 1, 2, 3, 4, 5. There are differences certainly in those grades, the back face being a lesser grade. So in other words, an A grade face is a slightly better looking piece of veneer than a 1 back, because it is expected to be the back, and more color variation, more defects could be available on that, or allowable on there. But here again, the core has nothing to do with this. So back to my last episode when I talked about what's important to you in choosing a quality panel. And if stability and durability is really, really important, but the appearance is not, then buying by the grade really doesn't help you. So think about that for a little bit. And remember this, when you go to a place to buy plywood or you're shopping online, you're going to see an A1 or a B3, etc. And again, that's just referring to the face veneers. So let's talk about face veneers. They are approximately, commercial made plywood is approximately 1/30th of an inch thick, but all the way up to about all the way down to about 1/52nd of an inch. It's very common to expect that an import piece of plywood is going to have a thinner face veneer, but really it should fall between 1/30th and 1/52nd of an inch. Let's just put that in common terms. It is thin, people, very, very thin. You'll also find some variation dependent upon the species that you've chosen for your face veneer. Walnut, for example, will always have a thinner face veneer because walnut, it's really difficult to get a clear piece of walnut. So you gotta peel it a little bit thinner to stretch it and go a little bit further. Regardless, it's always gonna be thin. There are some plywoods where you can specify a thicker face veneer, but this really comes into a very custom laid up application. More often than not, it's in situations where the face veneer, the quality of the face veneer is not that important. And really what's happening is that thicker face veneer is actually just a further extension of the core. I see this on a lot of marine grade plywood where the core itself is comprised of exterior rated or water resistant species, and it's the same species throughout. So there is no difference between face veneer and core. I know the Brunzil company in their Hecked Out and their Super Hecked Out product, Hecked Out is 100% Akume all the way through. The faces and the core is all 100%. Moreover, each ply is the exact same thickness. The Super Hecked Out product is 100% Sapele. And there really is no distinction between the face veneer and the core plies. It just so happens that's what's on the front and the back. And that's generally what you see. Ordering a traditional secondary species core with a thicker face veneer, it is done, but again, it has to be specially specified from the manufacturer. And this is a situation where, sorry, weekend woodworkers, they're really not going to do it for one particular panel. If you know of a cabinet shop that is speccing a thicker face veneer, that's a great place to call and form a relationship with, because you might be able to buy a single sheet from them, because they're more than likely buying it by the bunk or, 500 sheets, 1,000 sheets or whatever from a manufacturer, because it's really the only way to make it worthwhile. But I would tell you that a thicker face veneer drives the cost of a panel up exponentially. This is the most precious part of the panel because it's what you see. And really, knots and defects are not allowed in plywood. Now, you may see some of those little football patches and things like that, but when we're talking about the grades of veneers, and especially when we're talking about hardwood plywood, where there is a hardwood species on the face, knots and things are really not allowed until you get well down the chain past a D grade. And frankly, there's just not a lot of people producing that, because the logs that they're buying for veneer are 100% clear. The really, really clear stuff, it's going for veneer. And if it has knots and things in it, they are poked out, they're cut out, and they're patched with footballs. But even then, that's reserved for core species, where you've got a secondary species like Douglas fir or poplar or aspen in the inside core. The face veneers, they really don't allow for it. Now here's the next thing. The grades really talk in a lot of kind of ambiguous terms. We're talking about the face grade. We have AA, A, B, C, D, and E grades. And then on the back, you've got 1, 2, 3, 4. If I remember correctly, I don't think they go all the way to 5. But what is changing there is things like this is a really pretty face, highest quality face. They don't really, like in lumber grades, call out a certain percentage of clear because it is all clear. There's no such thing as a knot here or there. So it's something to be very aware of in that we can't really, everything is held to a higher grade. Everything is much, much clearer, if not 100% clear, when we're talking about these applications. So straight from the Hardwood Plywood Veneer Association, HPVA, AA, and I'm reading verbatim, a premium face grade for exclusive uses such as architectural paneling and interiors, case goods, and quality furniture. That's the actual grade as it's written. A grade, where AA is not required, but excellent appearance is still important. B, well, natural characteristics and appearance of the species are desirable. Again, these are the grades. There's no numbers here. There's no certain number of knots allowable because it's just not allowable in these face grades. This comes down to the grades of core, which we're going to talk about in the next episode. So do keep that in mind. All of these grades really are already, if we're thinking in terms of lumber, they are really, really good. When we start talking about the back grades, I'm sorry, I think I said 5. 5 is not. According to HPVA, it's only 1, 2, 3, and 4. And again, these just get progressively less restrictive. They allow more color. They allow more repairs. So that is where some of those footballs can come in, whether it be from splits or knots. This is allowable on the back faces. So when you're talking about a 1, 2, 3, or 4 grade veneer, there are going to be some things on there, but the defects have actually been cut out and repaired using an inlay, a football inlay or something like that. So here again, that's the good news, right? The grades, while they don't tell us a whole lot, they are 100% clear. Where things get kind of not difficult, but separating the wheat from the chaff, if you will, the cream of the crop is the organization of these veneers. So let's talk first about how the veneers are actually cut. The most common, the cheapest way to cut veneer is rotary cutting. So take a log, just like it's on a lathe. You're going to spin a log and you're going to come at it with a single knife and it's going to peel away the entire log. So you're taking a full log and turning it down to a toothpick and getting one super, super long sheet of veneer. This is probably the most common plywood you're going to see because, again, it's the cheapest plywood. This is what you will see in marine grade plywood because what rotary cutting veneer does is produce one long sheet. There are no seams. Looking at other ways of cutting veneer, like plane slicing, which we'll get to in a minute, requires cutting off a certain size of the log and then piecing those pieces together. And there are seams between those leaves of veneer. Rotary has no seam, meaning water can't get through it. Seam is always a place where water can get through. So if you truly want a marine grade panel, high quality marine grade panel, like a British Standard 1088 panel, it must be rotary cut. Otherwise, it won't meet that particular grade. But here's where you're going to see a series of cathedral patterns side by side by side all the way across that 4-foot panel because it's just peeled off the long log. Here again, cheapest way, probably the most common you're going to see. Plane sliced is just like if you were to plane slice a log into boards. You take a log and you just cross cut it, straight across its diameter, producing essentially the shape of a log. If you ever buy a flitch of veneer or even a whole flitch of lumber, it's stacked and kept in order so that you've got the shape of the log. It's just been cut into a bunch of little pieces. Well, veneer's the same way. It's cut into really, really thin pieces, like a 1/30 of an inch thick. This is being cut again with a large kind of guillotine knife, and it's just coming through and slicing off those pieces. So now you're going to get when you lay that up on a panel, you're putting those pieces, those leaves, side by side by side to make up that 4-foot wide panel. So you're going to see seams, but you're also going to see kind of a uniform of the log. And we'll get to how they're laid up in a second. But in general, you will be able to very clearly see here is, the diameter of the log that was used, and you can see that diameter next to it, next to it, and next to it, just stacked side by side. That's your plain sliced piece. Now you move into quarter sliced, and this again is just like sawing quarter sawn boards. You've taken, you're flipping that log on a quarter in order to get that either rift or that quartered grain, and you're slicing it again with a big guillotine blade. Here is a much more expensive way because there's a lot more waste generated here. You're getting a series of leaves that are then stacked side by side by side in order to make out that panel. But now what you're seeing is that rift, that perfectly straight grain face, or depending upon the species, you may see medullary ray fleck, like an oak or a white oak panel that is quarter sawn. You will see that appearance all the way through. Most of the time, this is done in the non-rayfleck species where the medullary rays are so small they don't really change much. They don't really show much, I should say. And what you get is a very uniform panel. You just get straight grain or vertical grain face all the way across the panel. It's a really, really pretty piece of plywood, but also very expensive because it takes a lot of veneer to cover up that face. Then the last piece or the last way of cutting is rift cut. And this is just like quartered, but now you're going for that grain. Instead of the grain being 90 degrees to the face, you're going around 45 degrees. And this will eliminate any ray fleck from those larger medullary ray species and just give you perfectly straight grain. You see this a lot in flooring, laminate flooring, where you don't want that medullary ray to kind of pop out. The average weekend woodworker thinks medullary ray looks great, but when you put it into a floor, that ray fleck sticks out like a sore thumb, and it's often very undesirable. So you avoid that altogether by doing a rift cut veneer to ensure that the ray fleck won't show up. Again, cut very much the same way, big guillotine knife coming through and just slicing off a piece of veneer. So those are the ways that we slice the veneer, but we need to look at how we actually organize them. So rotary, just one sheet, right? You just roll it out and you cut it usually around 5 feet, and then the panel is assembled, and the final panel, once it's pressed, is cut down to 4x8. But you're just using that one sheet rolled out onto the face. All the other methods, the plain slice, the quarter, the rift, all of that ends up with leaves of a certain width, depending upon the log that's been cut. And you have to figure out how are you going to stitch those together, line those up on the face. So book matching is one. Anybody who's ever resawn some of their own boards and glued it into a panel is probably very familiar with book matching, where you've taken all those leaves, and when you have plain sliced them, for example, they are stacking them in sequence. So you've got that log that's still intact. And now I'm pulling off a piece, kind of sliding off into the board, taking the next piece and flipping it over along the short axis. So you get that mirror book match between the two. And you're laying up a panel where it's book match, book match, book match, book match. So you get those mirror effect across the panel. Very cool look. The next thing would be a slip match, where instead of flipping that second piece across the narrow axis, you're just sliding straight off, almost like you're dealing playing cards right onto the poker table, and they end up looking very pleasing because it's all coming from the same log. It is in sequence. That's why it's called a sequence match. So if you were to number all those leaves all the way down, 1, 2, 3, 4, whatever, up to 300 leaves in a log, you're just putting them out. Leaf 1, leaf 2, leaf 3, leaf 4, and they're stacked sequentially across the board. So you get more, I guess I should say, more visible glue lines between those pieces, but you get a really good grain and color match because it's all coming across in sequence. The next thing would be a random match, where you're laying them on the board in really no order whatsoever. And this is where you're going to get certainly the same species in those veneer leaves, but they're assembled without any regard to color or grain match. So you get all kinds of variations and contrast and patterns of anything all across the board. This is really where a pleasing appearance is not required at all. It's just, let's put down a face veneer and who cares what it looks like. Then we have actually something called a pleasing match, where we're still using random leaves. They're not coming from a sequence match log. It may just come from a stack of veneer, but someone is going through them and trying to get a good color and grain match from one to another. It's a little bit more difficult because obviously it's not all coming from the same same log, so you may have to kind of mess around with it a little bit more in order to get that pleasing match, but there is some thought put into it. And then finally, we have a plank match. And this is where, again, you're doing that side-by-side match, but you're trying to actually highlight the fact that there are joints between these leaves. In many instances, a router may come back and actually put a V-groove in there. So it's actually designed to look like wall planking. We may see some sapwood along those joint lines. It's very random width in those leaves. It's also random grain in color, so that you very clearly want to see, here's a board next to it, here's another board next to it. Even though it's all part of the same plywood sheet, it's kind of meant to kind of look like faux paneling, if you will. Now, the next thing to consider if you have your book match or your pleasing match is, how do I actually space those leaves of veneer across the board? And the most common, again, would be a running match, where you just start laying down veneer 1, 2, 3, 4 until you get to the desired width that you need. But then inevitably what happens is you end up with this last piece of veneer on the far end of the panel that is thinner, narrower, I should say, than the other veneer. So, you lay down a bunch of even width veneers, 1, 2, 3, 4, 5, and then you lay your 6th veneer down, and when the panel is trimmed, it ends up being half the width of the other veneers. It happens. That's what a running match looks like. A balance match tries to avoid that and give you the exact same veneer leaf width all the way across the panel. And this requires some trimming ahead of time, a little bit of math to figure out exactly what it's going to look like. But here's the other thing. When plywood panels are assembled, they are assembled oversized, over that 4x8 sheet. And then once they're glued and pressed and cured, then they're trimmed to that final 4x8 length. And that last leaf, again, using the example, say we use 6 leaves across the board and they're all the same width because we used a balance match, but when it's trimmed, you might actually find that balance match is no longer balanced anymore. The good mills will try to remove a little bit from each side so that you get a balance. The 2 flanking leaves are of the same width, but they're going to be narrower width than the inner leaves that were laid out. So balance match is nice until it's trimmed, and then that balance match kind of falls away. The next thing is called a center match. And this is where we're actually trying to put a seam between veneer leaves right down the middle of the board, and an even number of leaves across that 4-foot width. So you're going to have, 4 wider leaves and 8 narrower leaves, but you always have an even number of leaves of veneer there. So you end up with that center line right down the middle, that center seam. That's a lot, right? That's a lot of different things that go into how the veneer is assembled on the face. And you may, if you're buying from a pretty good dealer, you may see a lot of this stuff. You may see, here is a cherry quartered running match panel. But now you know what that means, Okay, it's a cherry face veneer. It's quarter sawn, quarter peeled, I should say. Because, well, no, it's quarter, it's not sawn, it's quarter knifed. Is that a word? Peeled, I think, would still be the appropriate word, because it is a big guillotine knife that's actually peeling it off. It's a quartered veneer with a running match. So you know that it's going to be nice and sequential, but you might end up with one veneer that's a little bit narrow on the other side. And depending upon the grade, depending upon if it's a quartered match or it's a rift match, you probably won't even notice. You won't even see that glue line. So having a running match can actually be a good thing. That's the easiest way to assemble those leaves together. Or you may find that you're using there's even more in there. It can be a quartered book matched running match. All of those come into play. Or you could end up with a B-face veneer that is plain sliced, sequential matched with center match. All of those things will tell you how the veneer leaves are put onto the sheet and what the face is going to look like. So if you're buying sight unseen, these can be questions that you can ask. You may or may not get the answer, but any manufacturer will note these things. And these variations will actually change the price. There's a lot of work, quality control that goes into determining how those veneers are laid out on the face. So if they're spending extra time to give you a balanced match, you better believe they're going to charge you more for that balanced match. So if you buy a rotary sliced cherry A panel, an A1 panel, then you buy another rotary sliced cherry A1 panel, but the second panel is more expensive than the first one, you might want to look at how those leaves are put on there. is, well, if it's rotary sliced, there's not going to be, sorry, that's a bad example. If it's a sequence matched panel, again, because if it's rotary sliced, it's just one sheet all the way across the board. But that's going to be cheaper than a sequence match panel because you now have to stitch those veneers together. And there is actually a stitching machine that will come along and sew them together. You also have to take into account how they're put on the board and what kind of match, book matched or pleasing match or mismatch, and then how they're actually spaced on the board between running match, et cetera, et cetera. So all of these things will come into play when it comes to determining how expensive that sheet of plywood may end up being. Now, let's talk about the veneers themselves. These veneers are peeled from a log. Well, that log is dead green, and I don't think a peeling machine would be able to do what it does if the log was already dried. First of all, you can't dry a log. I mean, you could set it aside for decades, probably more than decades for a log to dry. And it's probably also going to check like crazy. And it's just, there's no such thing as a dried log. So this stuff is green. The greener, the better, because it's going to slice easier. If you've ever done any wood turning, you've taken a kiln dried bowl blank and turned it versus a green bowl blank, it's a night and day difference. And it's a wonderful, joyous thing to turn a dead green bowl blank. It just comes off. Of course, you get water splattering all over your face shield, but still, it peels away so easily. And this is what's happening with these veneers. So certainly they are very green when they're peeled. So in order to create a quality panel, those veneers need to be treated really well. So the other things that's going to affect the price, forgetting about, certainly the species that you choose is going to affect it. If it's something like walnut where it's harder to get good, clean, clear faces, that may be difficult. The other this is a species specific thing, but when you talk about cherry or walnut or even maple, the sapwood and heartwood distinction is very big deal there. So if you're requesting an all heart cherry panel, that is going to change the price, because you don't want sapwood in there. The interesting thing about maple is most of the maple we buy, what we want is the sapwood. The heartwood is a brown color. So you may find a maple ply that is called a natural maple panel, where there is actually going to be heartwood in there. So you're going to see that white sapwood and the brown maple. Usually that's a mismatch arrangement on the face, but that's colloquially known as natural maple plywood. And it's going to be cheaper than a maple plywood piece that's using nothing but sapwood. Getting a little off topic there, but there are certainly species, unique characteristics that will change the price of the veneer. The next thing that really changes the price of the panel, the overall panel, is how that veneer is handled. And that veneer needs to be dried. It's got to be really well dried. And you think about it, it's really, really thin. So it doesn't take that much drying. It's not like drying 4/4 lumber. You just slice a piece of shop sawn veneer that's maybe a 1/16 of an inch thick, and you'll see just how quickly it comes into equilibrium moisture content. But it will also want to curl up and turn into a potato chip. So they're trying to, when they dry these veneers, to keep them as flat as possible, while also getting them down to a uniform dryness. So they're going to be run through and baked in an oven to get really, really dry. In fact, most of the time, they're drying them beyond where they want to, because as soon as they pull them back into the factory, the panel starts sucking up moisture, that veneer starts sucking up moisture very fast. Think about how thin that veneer is and how easily it will absorb moisture, but then also shed moisture as the ambient humidity changes. Some some plywood plants actually are fully climate controlled and like enclosed production line, almost like a clean room, in order to maintain constant temperature and humidity so that the veneer doesn't react. So the veneer doesn't start curling up on you. Or say it's a figured veneer, and that figured veneer could start doing all kinds of crazy things because the undulation and the curl, basically the in grain and face grain alternations there, are going to cause it to do all kinds of weird things. There is some conditioning that is done with these veneers in order to allow them to lay flatter, but then the veneer itself may also be sanded. You may find that that veneer is peeled a little bit thicker, and then it's actually sanded in order to get a uniform thickness. And that's one really key thing. You need to make sure that veneer is uniform, because when you press that together, if that face veneer isn't uniform, it's going to not have a uniform dryness throughout, and it's also going to alter the thickness of the panel and make it not flat. Plus, the thicker veneers in one area are going to have a little bit more oomph to be able to curl on you, and that could cause the overall panel to warp. This applies also to the core as well. But because the face veneers are so precious, because they are clear, because it's what you see, it's how you immediately judge your plywood panel, these have to be treated with kid gloves, and they have to be dried absolutely 100% to uniform moisture content. And whatever that moisture content is may vary from factory to factory, from manufacturer to manufacturer, and how consistently it's checked throughout the assembly line will also, greater quality control, meaning those veneers are kept at a constant moisture throughout. That's going to raise the cost of the panel because there may be additional steps. Frankly, there may be additional humans in a fully mechanized line. There's just additional humans checking it, making sure that it's staying constant throughout. Then it comes down to gluing. Well, when you put glue on a face veneer, you're injecting a lot of moisture into it. So here again, if that thin face veneer is not of a 100% uniform moisture content, when additional moisture is added with the glue, it can react differently. It can curl in certain areas. It can introduce tension to that face veneer, which could actually cause delamination over time. So it is absolutely imperative that the face veneer be almost in a closed system to make sure that it stays uniform throughout the production process. When it's actually stacked into place and then pressed, put under immense pressure and heat in order to cure the panel, all kinds of crazy things can go on. And while the pressure of the press may push that veneer perfectly flat, if there is inconsistency in that veneer sheet, it's going to telegraph later. So if you've ever seen a plywood panel look perfectly flat and then you take it to another environment and it curls like crazy, or it starts to delaminate, that could be an issue where there was tension built into the construction because of an uneven dryness. Now, this applies to both the core and the face veneer. I'm focusing on it mainly with the face veneer right now because of the fact that it is such a precious commodity. To get that higher grade veneer is so very, very important. So there's a lot there. There's a lot to be considered here. And every single species is going to have eccentricities, unique factors that will either make it more expensive or less expensive. When you get into these shop grade plywoods and you're talking about birch ply, birch is a very uniform species. It's pretty easy to peel a birch log and get very good consistent veneer. It also behaves nicely in the presses and things like that. So birch in and of itself, being a shop plywood, the Baltic birch brand name, that material is of lower price tag because the raw material is not quite so difficult to get. You start getting into walnut ply and cherry ply, and the prices really start to skyrocket on you because there's a lot more work and labor and a lot more grading. And the veneer log itself has a much higher price tag associated with it. Those really, really high quality logs that the loggers cut down and they immediately see this is a veneer log. The guys that have been doing this for a long time can tell by looking at the bark and the straightness of that tree that this is going to be a veneer quality log. But you never really know until you crack that sucker open or you start peeling it. So you may find as a veneer producer, maybe you bought 10 logs and only 4 of them make the grade once you start peeling it. Now, those other logs are still peeled and they end up being used for back veneers, 1, 2, 3, 4 grade veneers. So, ideally those aren't just going on a burn pile or whatever, but there's a kind of this funnel that really tightens up really quickly in order to get that quality face veneer. The interesting thing is when you get to exotic species of veneer like sapele or mahogany, those trees are very uniform. They're also huge trees. The average sapele tree is enormous. So it's actually real easy to get a perfectly clear sapele board, and it's relatively easy to peel a sapele log and get veneer quality, face veneer quality logs. So certainly you're paying a little bit more because of the fact that it's logged across an ocean, it's going to be transported across an ocean, but you'll find that some of those exotic species plywood panels are either the same as some of the more expensive domestic ones or sometimes even cheaper because there's just less quality control required because the raw material itself lends itself better to peeling into a veneer. Whew, that's a mouthful. The key thing here in looking at buying plywood is trying to figure out if face veneer is something you're concerned about, then right away, appearance is a big deal to you. So, buying a AA or an A grade might be important, but what you might want to do is talk to your supplier and say, what grades of face veneer do you have? They may not carry. In fact, you're probably not going to find a lot of C grade plywood, hardwood plywood, unless it's specifically shot plywood and it's 100% birch throughout. Most of the places are going to be carrying B and higher. So talk to them about what does this look like, or you can Google these things. I know that HPVA, Hardwood Plywood Association, hpva.org, does have a booklet, the Hardwood Plywood booklet. I'm actually looking at it right now, that has a whole bunch of color pictures of various species and what their various grade faces and various arrangements of faces look like, and some of the specific characteristics of, say, cherry and birch and what's allowable, characteristics of walnut and what's allowable. And this is a book that it's not free, but it might be free now. I don't know. I'll have to look it up. But if it's not free, it's quite cheap. And it's actually very informative because it's got a lot of these pictures and it shows you exactly what you can expect from, for instance, a cherry plain slice book match running match AA panel. There's a picture in here. Now it's not an actual photograph. It's an artist rendering, but here's cherry plain sliced book match running match AA panel. And you really get an idea of what these various face veneers will look like. And cherry alone, I think there's 7 pages of images that give you a good idea, because cherry is obviously very popular. But the Hardwood Plywood Handbook can be really beneficial to give you an idea of what to look for. But you also can do some Googling. If you know what you're looking for, if you know you're looking for a AA plain sliced, book matched, running match panel, you can type that stuff in and usually get a lot of manufacturers that are posting images of what their version of that spec may look like. But the thing that I want to encourage you to think about is, if this appearance is a really big deal to you, don't forget about how you're going to use that panel. Are you making furniture? What size of panels are you going to need? Like, how are you going to cut down that 4x8 sheet? And how stable and how flat do you need that panel to be? Is it going to be joined to other things? Are there aspects of that construction you're using that may allow you to kind of press out a small cup or bow in that panel? Or are you using it as a full-size panel, in which case, how are you fastening it to a substrate? And will that pull any out of flatness out just by mechanical fasteners? But here's the other thing. What's the expression? You can't dress up a turd. You're not going to find a really high grade cherry face veneer on a crappy core. It doesn't make a lot of sense. You're using a really, really expensive grade a face veneer. You're going to put it on a good quality core, because more than likely the only people wanting that really high quality appearance, those people are going to want a stable and flat panel to begin with. They're going to want a panel that machines really well. It's not going to be full of voids. It's not going to chip and delaminate on it because of a poorly put together core. They're spending the money on a higher face grade. They're expecting a higher quality core on the inside. So while the grade A1, A2, while that doesn't really talk about the core, it's also silly to put a high quality face veneer on a crappy core. I'm not going to say it's not done, but generally that results in somebody returning it and saying, this is ridiculous. I ordered an A1 panel and it's fallen apart on me. So yes, technically it doesn't refer to the core, but it's kind of an unwritten rule that the core will be of a higher quality because of the higher quality face veneer that's put on top of it. Okay, that's a lot to talk about. Face veneer is kind of a big deal when it comes to plywood. Obviously, it's what we're seeing, it's what we're looking for. So if there are questions on this, please send them to me. You can go to lumberupdate.com. There's a contact form there, or you can send me an email to lumberupdate@gmail.com, or you can look me up on Instagram. I'm there at lumberupdate as well. I definitely want your plywood questions. I'm going to be focusing one part of this plywood series just on questions. So if you have questions about face veneer, fire away. Next time, we're going to talk about the gluing, actual assembly, and then we're going to save the core for the last part, because I think that's where most people run into problems, was with a poor quality core. So thank you, everybody, for listening, and I'll sign off this week by saying, go buy some plywood.